Okay, cool. So, welcome back to our podcast episode number 3 for Entropy. And it's been long from last episode that we have recorded something. I think after we spoke last time, there has been multiple technological shifts. One, of course, was DeepSeek R1 release, and we were thinking of doing something around it. That did not happen on time, and later Grok released, and there is a quantum leap from Microsoft side. I was listening to that recently. So it's all interesting, fascinating. But what I think today's episode we are going to cover, it's structurally very simple, logically 3 items ideally. So to cover whatever has happened in the gap of what we have done last time, we will start with explaining maybe looking at the workflows and what is the difference between an agentic workflow and the normal workflow using AI. And then we'll look at how the reasoning models fit into that. We will look into sample application development using that for an agentic workflow. Basically, we'll integrate a reasoning model into that, and we'll look at how we get into the paradigm of multi-model integration for different stages of the product development. Then I think we should discuss deeply about deep research, which is the last leg of what is being released. So we before we get into the sea of the reasoning models, I would like to know how did you digest the release of DeepSeek, maybe the quantum chip that Microsoft has released, and other expansion in the tech world. So I would like to hear from you, and then we'll get into the topic of today.
Yeah, I mean, a lot of things came out, in quick succession. I'm already, feeling left out and really far behind. It's very difficult to catch up with the new updates that's coming. You know, so DeepSeek, even before we could deep dive on what really happened, what it is, as you said, rest of the things came in quick succession. So overall, I was wondering why DeepSeek was such a big news. Then there is this, there is I think a 5 minutes monologue from this guy, David Sachs, who's the new crypto AI czar in the US, which is, I think I found it as the best analysis so far. Quite interesting. What he says is it's a mix of many open source versus closed source debate, US versus China debate. It came in the center of all these various debates. That's why DeepSeek became so important, so viral in the end. Okay. And at the same time, all the initial 6 million training cost, all these news about how cheap it was, all those were debunked later. Even they spent a lot of money on it and all. But then finally they had good new innovations to make it cheap and make it really good. So DeepSeek, yeah, I was more interested in knowing why it was such a big viral sensation, and these things explain it. uh, then
Great.
go ahead.
And what? How do you see the quantum leap? Did you get some time to read through that?
No, I'm yet to even watch that Dwarkesh Satya Nadella, interview. So no idea, and I have not been that keen on it. As you know, it's your stuff, so you can tell us a bit more.
Yeah, quantum is extremely interesting. So, my initial thought was maybe classical computing is getting replaced by quantum, which is not the case. And I like the podcast by Dwarkesh and Satya. Satya is extremely clear in his head on what is it. If you look at his speeches, he explains the complicated stuff in 1 or 2 lines, and that is extremely fascinating. And he told quantum is not shouldn't be data heavy, but it should be like understanding different states of the same matter. That means you have different dimensions of same thing, and then you wanted to represent that. Right now in classical computing, you cannot do that cheaply, and that is where the quantum will help you. So what I understood is the classic computing and quantum computing along with GPU is going to coexist in the same chip. Right now, it's not possible. There are a lot of issues of handling it. But if you remember, we had a chip with CPU, and then we got GPU slots in there, and then we got into the mobile phone. Similar way, maybe a quantum chip and slots would come in, and maybe we get a coexisting factor, a bigger hardware which will do all this thing, and we will have computing task which will look at, am I doing a classical computing task or a GPU task which has to be parallelized, and then do I have to represent state, then do it in quantum. I mean, that's how it is going to be, and it is extremely clear. And I think that is what
How,
Satya is looking at.
how close are we for this kind of an AI kind of breakthrough where we have practical applications on quantum? Should we start looking at it already, or you know?
I I think it's important to understand the qubits and superpositions of matter, and
Mm,
understanding how the computing will change for that. Because
yeah.
if you are in pharma, and pharma is where this will play a key role, because you have to represent the matter's different dimensions onto this, then this is the way. You already have seen the protein folding invention and all that pieces, but going forward, chemical substances representation in quantum, I think it's gonna have a large lasting impact on our life, how we invent medicine, longevity, and all that pieces. I think we should look at that fact later, but it's good to deep dive into that and learn more about it. But it's really fascinating to see Microsoft inventing a chip, because the most complicated issue of having a quantum chip is it is extremely error prone. If you put it into a normal environment, it can have uh, an error because of your mobile phone's radiation is hitting it. It can, even if a small dust can cause this error. So that is the problem, that quantum can never leave the lab, and this first step of Microsoft would actually help us bringing that lab environment to an actual chipset which we can use, and that's where it is. I have my bet on it. Yeah.
Entropy, controlling the
Entropy.
entropy. Yeah.
Correct, correct.
That's a nice series. The quantum makes me think about this particular sci-fi series called Dev, DEV,
Yeah.
Dev. I mean,
Maybe, yeah.
yeah, it's pretty good series. I think only 5, 6 episodes, but
I
really
think
talks
I've
about
I've I've seen it. Yeah, yeah, yeah.
yeah, yeah. I mean, predicting the future with
Future.
quantum, something like
And
that.
I
Yeah,
think even representing the physical world in the universal matter, you need a quantum
yeah.
representation of that, and that's
Right
the
now, we
only
have
way.
binary 1, 0
Yeah,
representation. Quantum feels like more of the actual world, what we live in,
correct.
that's the only thing which can represent the entropy of the
And
world, probably.
correct,
Yeah.
correct. Yeah. But we can leave that behind, and we can come back to our
Right.
topic.
Yeah.
Another interesting fact which I learned about DeepSeek is, I was learning about the LLM architecture and how it is evolving, right? And this transformer layer, inside that we have this attention block, and DeepSeek has used something called a mixture of experts, MOE, and that has caused them uh, to not to activate each of that layer every time, because you only need to identify the right layer expert for you in the attention layer and then activate that. So there is a routing logic which will classify your tokens and then route it to the right
And yeah,
expert.
I saw that as well. I mean, the way I saw, I mean, I don't know deep into the technical details, like, but mixture of experts. This was an existing architecture since quite a while. I think Mixtral. I, I don't know
Correct.
if it was
Yeah.
used by Mixtral, but mixture of experts was very much in use. But the number of experts in DeepSeek, I think it's very high, 256.
Correct.
I mean, I heard this in the Lex Friedman podcast with Dylan Patel and one more
Yeah.
guy, right?
Yeah.
And So they were talking about how efficiently they use mixture of expert compared to all the others. Yeah, right.
Correct, correct, correct. I
This is where
think
they, but it's still underused, it seems, that tech selecting the
correct,
right
correct.
expert for challenges.
But all those people, when they said, you don't look at foundational model building, you'll focus on application. I think now I clearly understand why we should look at foundational model building, because that architecture is evolving and it is changing every
Yeah.
day. And I don't think if you don't have a handle on that, any nation can do anything. So I think it's important to learn the current architecture and evolution of that, how to optimize it. I think it's
Yeah,
very, very
while we are
critical.
saying frontier models are already commoditized and it's done and dusted, we only focus on application layer. As you said, it's not done and dusted yet. Just so much is evolving. DeepSeek has
Correct,
shown us that this is still evolving, changing completely efficiency, intelligence. Grok 3 reached the 1400 Elo score, and
correct.
things are changing so fast. So even that layer is completely being innovated, not only.
Yeah, yeah, yeah. Now let's get into the topic of reasoning models, and then we'll plug all these things in. So I was trying to figure out a extremely simplistic answer on what is this agentic workflow, right? And it clicked me 2, 3 weeks back. And correct me if I'm wrong. I mean, this is what my understanding is. Okay, so there are workflows and there are agentic workflows. With both of this can be developed using an LLM or an AI model. So let's take an example of a workflow. Workflow is like, as a person, it will take, let's say, 3 step or 4 step or 5 step, 1 to 5 steps. Clearly, that is the only way that it will work. And as a human, you control the input and output to that each of that step. But the calculation of what is happening in each of the step is done by a model, and that is a workflow driven application. Okay, so it can be a replacement for the rule engines what we have. But what
Yeah.
is fascinating is the agentic workflow. And what I understand is, and that is where what we are going to deep dive next. Agentic workflow is something where you want to reach from point A to point B, but you don't know how many steps you have to take. Okay. And all the steps that you have to take will be determined by a model. And model will interact with the system, understand the context, and deliver a value. And maybe a human will interact back to that system and give more input. And then it might end in 2 step, it might end in 5 steps, but eventually the model will decide, what is the resolution for this and resolve it. And that's what is an agentic workflow in my understanding. Do you
So you're
agree
saying
to this?
five, let's say 5 steps in a workflow. I mean, there is one way each step can be an LLM call, which will be mostly even still decided by humans, these 5 steps, but then
Correct,
the steps are executed by LLM.
correct,
Another part,
correct,
what is it? Is completely there is, yeah, humans in the loop, but the whole workflow is decided and executed by LLM, and there can be humans in between if needed, right? The
correct.
decision itself is made by LLM on most of these. Yeah, I mean, that's one way. When I think about agents, okay, let's say back in 2023 or mid of 2023, I mean, LangChain, when we play with LLMs on the first days, okay, like within the first 6 months, I was trying to attend a hackathon, participate in a hackathon where we could chain together. LangChain was out those times, and we could chain together LLM calls. And I understood at that time that's a rudimentary agent, basically. Even the chat GPT is kind of a rudimentary agent, right? You ask something, it executes something, finds the information, gives us back. It's an agent. But now, when we think about agents, or people even say, a year ago everyone was talking about agents, even now people are talking about agents, adding agent word to anything that they please, you know it became too repetitive. And this guy called Hamel Hussein, I attended a course by this guy. He was saying, like, stop calling it agents, let's say tool calling. Agent is nothing but tool calling. But we have gone beyond that now. For me, how I understand agent is agent, you know it's LLM calls chained together, but those LLM can access some tools to deep search, take a deep search or deep research, or every lab is coming up with a deep research stuff now. Google in December, OpenAI copied in Feb, Grok again copied it quite last week. So all that is, I mean, we can call it as real agent. You ask a question, it goes, makes a multi-step planning, searches the web with a tool, comes back and put together all that research and show it to us. So for me, it's one of the first real good agents we can see from these top model labs. But the agent that you're talking about is more of an enterprise use case agents where we
Correct.
put together, various things where you can call it as a workflow or a pipeline or, I don't know. Yeah. Agent is a
Yeah.
confusing word.
So
There are lots of interpretations for this.
correct. So, like I said, if you simplify it like a model taking decision on how to reach a particular destination, and it'll take
Yeah.
how many hour steps that it wants. So basically, you're giving autonomy to a model. So it's a starting point, right? Now you're giving autonomy to model to reach from point A to point B. Later, it
Yeah.
can be more for more complicated tasks. So this will evolve, but this is an extremely good use case. So I have a sample use case which I wanted to discuss with you on an enterprise level. How do we do this? So the example that I have is from Deeplaearning.AI. They have a free course, so it's a shout out to them for making that course available for free for everybody. I think everybody should look at it. It's for coding with O1. So it's basically a prompting with O1 course, and they're beautifully explained a sample use case there. Now I wanted to take the same thing and then explain it back in our context. Basically, that's what I'm gonna do.
Yeah.
So this is basically imagine that you're a airline company and you have a huge policy document on how to book a ticket, how to cancel a ticket, how to give a refund to a ticket. Imagine that it is all in your policy document. Now, if you want to completely automate the workflow for an agent interacting with a human who has booked the ticket and solve his issue, it's basically a customer care agent that you're developing. It's a complete chatbot, but it is purely driven by AI. If you want to do it, how do you do it using the new LLM paradigm is what I'm going to discuss about. And fascinatingly, they have used the combination of a reasoning model to plan activity, then give it to a 4O model in GPT. So basically, it uses O1 model for reasoning and 4O model for kind of executing the task. That's how it is going to be. Uh, you
Ah,
know, yeah, OpenAI is complicated naming, but O1 is the reasoning model and 4O is actually the GPT model for them ideally. So that's what we're going to discuss. I'll share my screen. Maybe we'll go through the use case a bit.
yeah.
So hope you can see the screen.
Yeah.
So
Can see the screenshot, but zoomed in screenshot in a way. Yeah.
yeah, correct. So the KB article that it is pointed here is
That's the
basically
airplane policy documents, as you said.
policy
That's
document. Correct, correct. So it will go to an oven model, and basically before you give it to a 4O agent, 4O agent will decide how many steps it has to take to solve the customer issue, right? But before we get into that, you need to give a prompt to 4O agent, right? If this is the issue, maybe this is how you solve it, kind of a prompt example. So that is what we have to develop as a routine. A routine is nothing but a policy which you will derive out of the policy document what you have. It'll have step-by-step instruction on how to deal with a customer issue, ideally. But it will be in a prompt language model so that the 4O can understand. So basically, Owen is planning this activity which is executed by 4O agent. That's how it is going to be. And then you will
okay.
do a multiple stages of evaluation of this routines. And then you will pick one exact routine, which is extremely important. For example, we know the AI cannot be used for a mission critical application, right? LLMs. That is what everybody are discussing. But imagine giving refund is a mission critical workflow for an airline company, right? How do we accurately decide to give a refund is also from a policy document. So that this will explain how it happens. So
Yeah, I'll
basic,
add one point, the one segue when I was saying before, even though agent call were very, it was apparent even mid of 2023 that, we are going agentic in a way. But at that time, we couldn't really use agents because models were not capable enough. Like now, O1 or GPT-4o, these are reaching almost human level, eval. And this is why agents are. We can use it more mission critical. Even we can let the model do its own thing now, well, because we are more confident on the model capability. You know.
correct,
Yeah.
correct.
Yeah.
So this will explain how are you going to do development and testing of this application, and then before you hit production, right? So step one is to generate a routine from a document. Step two is evaluate that. Step three is to improve the routine, and then finally decide which routine you will go to production. That's how it is.
Okay.
Um, so this is an example what I meant. So for example, I would like to get a refund is a customer request,
Yeah.
and customer information is like he gives his flight detail, first name, last name, and all that thing. And then the expected result of this is process full refund. Maybe he has a legitimate reason to get the refund. That's the uh, criteria that you end with, right? So you can see O1 is generating a policy, then it is input to 40 agent. Then human is asking, I would like to cancel my flight. Then, could you provide booking references? It provides booking references. It gets into multiple levels of interaction with customer. So this is not controlled by
Owners use you know, while the user asking question, Owen is not engaged. Owen is engaged even before to generate all the policy
correct,
planning. Okay,
correct,
fine,
correct, correct. So
fine, fine.
here the reasoning model ends once it generates a policy. It is before the production. Rest
Yeah,
all the activities taken care by the 4O model. And humans as developer, we are not deciding how many times you should interact with the customer. That is decided by 4O ideally. So
yeah.
it has already asked 4 questions, right? It can have 5 questions, 6 questions till the 4O agent is satisfied with the answers before it hits the processful refund. It will continue this loop ideally. I mean, that is what we mean by giving full control to 4O to decide whether you should do a full refund or not. Ideally, that is what is happening here. Uh,
Yeah, and then, look at if needed, if it has gone wrong, given refund without the actual, if it was not a legitimate case, later review it, improve it again, uh, find out, some kind of evals to find out if this was good or not, check customer feedback if they were happy or not, and then again use it to feedback later. But yeah, this is good.
Correct. So if you look at the conversational prompt, this is a prompt given to the reasoning model, which is O1, to
Mm.
generate the policy document. Okay, so if you look at it, it will tell you, review the customer service policy carefully to ensure that every step is accounted for. It is crucial for organization. The instructions are into so organize the instructions into a logical step-by-step order. That means you'll read the document, define the step-by-step order for what you should do for each of the cases. So this is basically describing what one should do. And if you see below, this is basically a workflow defined by O1. So basically,
Mm.
step one is to confirm your identity. Whatever the question is, you tell who you are and give it details about it, and that is it. And then second is listen and understand the request. Third is check the ticket type, what type of ticket it is. And then, for example, if it is a process refund, and then get into the loops of that kind of a thing. So basically, this is the response back from O1 by reading the document. This is the policy step by step that you should do. Now, this will go as an input to 4O agent. That's how it is going to be.
A single agent. It goes to a single
Single
4
agent,
agent. Yeah.
4O
Okay.
agent. Now, it's huge. Like, for example, uh, when you develop this application, you should have this kind of a tabular data where you define what some sample requests, some kind of details about it, like full name, booking reference, and all that thing. and what is the expected input and what is the expected output. This will look like your system test cases for software engineering, which we would have done last, a few years back, right? It's exactly same thing, but you're dealing with data here. This is more about data quality. The better quality and better accurate data that you can provide into evaluating your results, which is coming out of Origin, your application will be also better. So y- sometimes it might be getting into the territory of overfitting into this segment, but for mission critical applications, it is important for us to understand this context and extremely, stitch this together ideally. Now, from this table data, this is the result that we got. The accuracy is around 70%. Not getting into details of that, but I'll
Yeah.
walk you through how do you decide an evaluation of this. For example, imagine that you have done the run, you have generated the policy, and then you have inputted into agent and you tested the output using the data set that you have provided. Now, this is one round of your execution. Similar to
Mhm.
that, you would have executed 3 4 times. You can execute n number of times till you get a result. If you look at the first graph, you can see the accuracy is reached 82. So this dot is first round. This is second round. Second round, it has reached around 76 percentage, and it was reached 82 percentage in the first round. This is I have run it. Imagine, okay, and the second graph is actually you have run it. Imagine. So you can see
Yeah.
in the first run, um, it is nowhere, and second run it has reached suddenly a peak of 87% of accuracy. In third round, it has dipped basically. So if I had to choose from the first run, first round of execution, this whatever routine that O1 has generated, this is what I will choose. But in this case, I will not choose the last routine, but rather I would choose the previous routine because this has given me the highest accuracy. I mean, so this is how you generally evaluate the output from the agent, and then you decide which routine to go with, and then you pick this routine, put it into production, and then you get into the workflow, and then maybe you evaluate in a staging environment and then production environment. You look at it and you iterate it over and over again. But this is how you start ideally. So this you can see a software development life cycle, right? You plan it, then you test it, and then you pick one particular version of your software which you wanted to put it into production. But in this case, our version is mostly around the routine data that you wanted to put in, more not only software as in code, but this is mostly a natural language input as routine that you're defining. And then finally you move to production. I mean, this is a practical example of, first of all, how to use a reasoning model. Second of
Mhm.
all, how to mix it with the normal model and create an application around it. Third, how do you test it, evaluate it, and move to production? I mean, I find it pretty interesting for it to do this ideally.
Yeah.
So
Okay. It's more like, you use GPT-4 as an agent. Okay. That agent can do something. Yeah. It can call you know, it can call some APIs basically, right? O1 is used
correct,
for planning, and then GPT-4 is used for, so some very costly, expensive models are used for planning purposes. Some small models, it'll go and execute stuff, because that's where we don't know how many tokens are generated, how much cost, or if it,
correct, correct.
so you'll
So
use
this is
smaller
a
specific models too.
yeah. Use this as a simple skeleton example where you can build something around it, and this is how it. People are confused. Practical implementations of all these things, right? And I find it very helpful for me to understand how to use a reasoning model, how to use a normal model, when to use what, how to evaluate. I think this cleared all the clutter in my mind. So I thought re-iterating all the same example would help
Yeah,
other people also.
it'll be great if you also put this in the link, in the, yeah, YouTube description somewhere. The link to this course can be
Correct,
very,
correct,
very useful.
correct. Yeah. Okay, now let's get into the last topic of the day, which is deep research. And I am more than interested to understand what is it, how is it different from reasoning models? What are the general use cases of it? If you can explain
I
few
think
things
it's
around it,
very
will be great.
similar to, yeah, I think it's very similar to what you just showed. You
Okay.
know, first it plans, so you'll have that complete list of plans, and then it goes and execute each of the step. And while executing, I mean, what deep research can do is search the web. You know, it can go to the web. That's the tool usage. That's the actual agentic behavior, where it goes to the web, it searches things, it comes back. And there is an interview with these two guys who came up with the idea, who the PM and the tech lead of actual Google Deep Research, which came out in December. That's a nice, I don't know who did this. Yeah, this is by the podcasters Latent Space, Swix. They interviewed these two guys. It came out a few days ago, probably. Very good session to understand from these guys how and what all they considered while developing this, now very popular idea, deep research, because everyone is copying. So obviously, this seems to be an idea which already clicked, right? Uh, one of the interesting part, I mean, I was a user even when Google released it. I was a user, I was using it for some research, give it some research topic, and I saw it went through 800 different sources, I mean web searches, to give me the output. So for me it will take maybe weeks to sit together and do a research like that. Okay, I think one of the question I asked was like, do I show me Indian, the GDP and the number of working population in India by sector. Okay, quite interesting to see. Like still 50% of Indian population works on agriculture sector. Rest 50 is services plus industry and stuff and deep dive. For me myself to go and search, it'll take weeks. But this took 10 minutes to go and search the web and compile it very nicely. Interesting part I found from the interview with the inventors of this is, uh, in the planning steps, each step it goes and gets the data, and then it can think again and plan again. It's not just one plan and it goes and executes, comes back. It comes back with the result. Again, it can go and plan based on that data. So it can self-adjust based on each step. It can go back and correct itself. So it's really a very good example of one of the first uh, great agents that we have. Coding agent. We have coding agents for sure, support agents, I think a lot of people. Now the research agent is really a third killer use case for agents, not the kind of agents that you are talking about in the enterprise world, but the model itself. Or but yeah, I found it very fascinating. Then OpenAI O1 came out as a copy of it, but they made it much better for some reason. Because when you ask same research questions to OpenAI Deep Research, the output is mind blowing. It's let's call it a PwC or McKinsey agent, you know, who companies pay a lot of money for, and that comes out in 5-10 minutes. We already in our company, one of the project that I'm leading, I already tried to use deep research agent. Like how you used O1, deep research internally uses O3, which is not available to anyone, right? It's available only through deep research at the moment. The latest, they're cutting edge O3. So we try to use it, and the results are crazy. It's incredible. Results are incredible. Uh, for more, we can put this also on the show notes. The interview with the inventors of deep research. It's very informative.
Great. I think it's pretty interesting to look at practical aspects of all this agents, and as I understand, it is going to be much more intelligent going forward. And I saw Satya's comments on AGI, and he said AGI is some
10%
random.
on the yes.
Yeah, it is not the right way to measure the progress. Rather, you should ensure the countries are growing by 10 percentage, then everybody are getting benefited out of technology. That is where the real, change has happened. But otherwise, it's just a nonsensical paradigm for everybody to look at. And quoting the Meta's chief scientist word, I think if you really want to reach an AGI level of intelligence, we should stop using LLMs also. So we should look at what is coming next. And the language itself has its own limitations for us to interpret a lot of things. So we shouldn't be, if you look at all the examples that we showed today, it is purely the natural
Text
language
in,
driven,
text
text
in, text
driven.
out. Yeah.
Yeah. So
But
I
then
think that should
all
change.
text in, text out. But then even deep research, their next one is image in, audio
Yeah.
out. That's where we are going. But I understand what Jan LeCun said. We should completely go away from LLM and look at other things. But I think
Yeah.
that's where we are going. Yeah.
Yeah, with that note, I think let's combine video, audio, text, everything and create a world representation using quantum and then have GPUs in a single chip. Let's create a different world using classical computing and quantum computing and GPU together. Let's get into that aspects later, but um, thank you for joining today. I think we have covered a good content for us today. Maybe next time we will deep dive into. I'm playing a lot with cursor these days, creating one particular application. Maybe we'll get into the discussions around cursor
Yeah.
next time.
Right. Vibe coding. Yeah.
Web coding, yeah. So let's see. And thank you and have a nice weekend.
Thank you. You too. Bye.